Hello everyone from Math 1340, Statistics. It's Professor Winson here again with a video on Section 2.2 titled Histograms. There's more to the title of the section in your OpenStax book, but we're only going to cover the part of it that's on these things called, these types of graphs called histograms. Okay, so you're going to see in the Week 2 module there will be a page for Section 2.2, Histograms. You'll open that page. Ask you to read Section 2.2 of your OpenStax book. There's a link to it here. Click on it. It'll open up openstax.org with Section 2.2 from your statistics book. As I said, it's called histograms, frequency polygons and time series graphs. We're only covering the histograms part of this, so if you want to read further about frequency polygons and now you've already seen time series graphs a little bit when we did our section in the last section 2.1 when you talked about line graphs. Those were some examples of time series graphs, but again, we're only covering the histogram stuff. So just like any other textbook, read the bold words, read the definitions, tables, charts, graphs, whatever. Go through examples, and to try things on your own. I'd recommend doing that just to get practice. When you read through an example and it ends with show solution, I'd say try to do the example first before you look at show solution and see how you did. All right. Using the calculator, some more try-its and stuff. Okay, and that's it, right? If you just read up to here, you don't have to read the frequency polygons section or the time series graph section, right? So you can stop right before frequency polygons. All right, then you have here's the link to the KnewtonAlta homework that I'll be going over with in the rest of the video in a little bit. And then below are some videos related to the objectives. Here are just some of the objectives. There are actually 4 objectives in the KnewtonAlta assignment. It's just that 2 of them are practically the same thing. One's just called an extra practice, this create and analyze histograms and frequency tables with group data. It's kind of repeated in an objective. Alright, so you can watch the video in Canvas or just click on the link, watch it in YouTube. Alright, that'll pop up. And if you want to find other videos, just copy and paste the objective into YouTube and search for other videos related to the same topic. Alright, so I'm going to get into the homework. Alright, KnewtonAlta Section 2.2, Histograms. It's going to have you load it in a new window. Now I'm in teacher mode, right? So I'll show you what it looks like. I'll show you what you're going to see as a student. Just a second here. So preview as student. All right, and hopefully by now you've done several of these assignments, so you know what things are going to look like. You'll have the title up here, again without the word preview. Your mastery bar, the objective, the question that you're looking at is currently about, and if you click down the down arrow, you'll see all the objectives, and the it'll circle the one that you're currently on, and you can see the progress made on every objective, and it also estimates how many questions you'll see. So everyone's at least 4 questions. Again, the more you get incorrect, the more questions will be thrown at you. Right, so try not to guess. Try to get through it in as little time as possible. All right. So the first objective here that's thrown at me, and you might see a different objective first. The questions I see won't exactly be the same as the questions you see, but just use my videos as a guide. Because the objectives are the same. Right? All 4 objectives are the same. And the way I would do problems, the way I'm going to do these problems is the same way you will, right? Or you should. So create and interpret histograms. Now if you've done the reading and watched some videos and taken notes and all that and done some exercises and you feel comfortable, with the material, you can start trying to answer questions right now, right? But if you're still uncomfortable or you still don't know what this means, the first time you see an objective, I would recommend clicking on More Instruction and then View Instruction. Or if you're struggling with a problem, don't guess, click on More Instruction, and it takes you to some reading or some videos related to that particular objective. So histograms. Now histograms are just bar graphs, but they're connected bar graphs. You see all these bars are touching. And remember in the last section, for bar charts, bar graphs, the horizontal axis was usually represented, representing categories, categorical data. This time, when we're talking histograms, the horizontal axis will also be numerical. So you'll have a numerical horizontal axis and a numerical vertical axis with a histogram. So a histogram is a graph that consists of contiguous, right, adjoining boxes touching, right, boxes, and can show you the shape, the center, and the spread of the data. One advantage of a histogram is that it can readily display large data sets. A histogram has both a horizontal axis and a vertical axis. The horizontal axis is labeled with what the data represents, right? Like your number of books. Again, it'll be a numerical value, a quantitative variable. The vertical axis is labeled with either the frequency, right? How many are in each range, how many, or the relative frequency. Remember, relative frequency was just percentage, so you could also see relative frequency or percentages on the vertical axis. So again, you can read about the example above. All right, so their example here. Given the histogram above, right, this histogram, how many students read greater than 4.5 but less than 5.5 books on average each month? So go to the 4.5 to 5.5 on the horizontal axis here, 4.5 books to 5.5 books in a month, and then the height of the bar will be the frequency, which looks like between 4 and 6 here. So looks like 5 students. All right, and then look at that, and the height of the bar is 5. So 5 students read greater than 4.5 but less than 5.5 books on average each month. Okay, so it should be easy, just like with a bar graph. Should be easy to read these and interpret them and get information off of these pictures. We'll see later also how we're going to make these pictures by hand, and also how we're going to make a histogram on a calculator. All right, so key terms, definition of a histogram again. All right, so I hit continue after reading through the instruction, and we're given a histogram. All right, so again, numerical horizontal axis, and then the vertical axis is either frequency, count, or relative frequency, percentage. Here it's just frequency, counts. Given the following histogram for a set of data, how many values in the data set are greater than 6.5 but less than 9.5? So here's 6.5. Again, the horizontal axis will represent the values in the data set, and the vertical axis will just be how many there are, frequency, or what percentage, all right, relative frequency. All right, so we have 6.5 to 9.5. So that means I'm looking from here to here, I'm looking at these 3 bars. Looks like there are 3 data values, right? The height of the bar is the frequency. There are 3 data values from 6.5 to 7.5. There are 6 data values from 7.5 to 8.5, and 5 data values from 8.5 to 9.5. So from 6.5 to 9.5, there are 3, plus 6 is 9, plus 5 is 14. All right, so there are 14 values in the data set between 6.5 and 9.5. All right, again, hopefully very easy to read, just like a bar, any old bar graph. Okay. All right, so I continue, and here's another question. All right. All right. The students in a statistics class record how many movies they have watched in the previous month. The data are listed below, and it looks like they're listed in ascending order, lowest to highest here. So a student watched one movie, another student watched one movie last month, another student watched just one movie. These 7 students watched 2 movies, 3 students watched 3 movies, 2 students watched 4 movies, 1 student watched 5 movies, and 1 student watched 6. Which of the histograms below correctly represents the data? Alright, so let's see here. Now, you see the little horizontal axis represents movies watched, vertical axis represents frequency. If I were making a histogram for this, here's how I do it by hand. All right. Now, let's see if you can see this here. Okay, so hopefully this isn't too small. I'm testing this out for this video here. So I make 2 axes. All right, horizontal, vertical. The horizontal axis, remember, is going to represent the actual data values. So these values here are, all these numbers represent number of movies watched. In that last month, right? Number of movies watched for the horizontal axis. The vertical axis will just represent a frequency. All right, or you could do percentage as well, but we're just counting this time, so frequency. So the frequency one's easy. I'll just put 0 movies, 1 movie, 2 movies, 3, 4, 5, 6. All right, 6. All right. Now all the data values are just whole numbers. All right, all these data values are just 1, 2, 3, 4, 5, and 6. So I can mark those off here. 1, 2, 3, 4, 5, and 6. But when we make a bar, when I go to make a histogram, bars need to be connected. And I'm going to make it so that, the bar for number 1 for one movie, so that the number 1 is in the middle of the bar. So I'm going to do this in a different color here. Right, I'm going to make this so that the bar for 1 is in the middle. Now if 1 is exactly in the middle, that means that the left value is 0.5 and the value on the right is 1.5, right? So that 1 is exactly in the middle. And then how many students watched one movie last month? There were 3 of them. So the height of the bar is 3 high. I go up to the frequency of 3. And I'll color that in. But you see how there's from 0.5 to 1.5, so that 1, the value of 1 there is exactly in the middle of the bar. And then it's connected to the next one. And then every bar is going to have the same width. Right? Every bar needs to have the same width. So this is 1 unit, right, from 0.5 to 1.5. So I go another unit from 1.5 to 2.5. That way, 2, the next data value, is in the middle of the bar. And how many students watched 2 movies, right? Well, we count them. There's 3, 6, looks like 7. All right, so 7, I'll put 7 up there. 7 students watched 2 movies. So from 1.5 to 2.5, I make a bar with a height of 7. And there's the bar representing how many students watched 2 movies. And then 2.5 to 3.5, we'll have 3 in the middle, and I'll make a bar around that so that we get a bar for how many students watched 3 movies. Well, how many students watched 3 movies? 3. Right. So another bar with a height of 3. And then from 3.5 to 4.5, how many students watched 4 movies? Just 2 of them. So with a height of 2, the next bar. And again, every single bar has the same width. All right, every single bar is 1 unit wide in this picture. Again, they're not always 1 unit wide. All right, just just know that the bars have to be the same width, whether it be 1 unit, 2 units, 3 units, whatever, half a unit. All right, then from 4.5 to 5.5, that'll give me 5 in the middle. And then you'll have a bar for how many students watch 5 movies. Just one student watched 5 movies. And then from 5.5 to 6.5 will give me 6 in the middle. And how many students watch 6 movies? Just one of those as well. All right. And again, so there's 6 bars, and every single bar has a width, which is going to be called the width of the bar. The width of each bar. The width of each bar is called the class width, and that was 1 unit in this particular case, just in this case, right? And again, in other cases it'll be a different number, but just know that every bar needs to be the same. But this is how I would create a histogram for this set of data by hand. And again, hopefully this wasn't too tiny. If it was, please send me a comment, send me a message, and I'll change it I'll change my approach to this for future videos. All right, so getting rid of that. Well, let's scroll down and see which one looks like that. So not that one. Well, actually that one. Right, that first one looks exactly like the one I just made. If I compare them. Now you can't see all of it, but so it starts off with 3. Oh no. Starts off with 2. So that's no good, right? Starts off with 2. This one starts off right 3, and then 7, but then 2. Here we go. 3, 7, 3, 2, 1, 1. 3, 7, 3, 2, 1, 1. It's this third picture. Let me get rid of my picture there. Right, 3 movies. See 0.5 to 1.5. That's got 1 in the middle. All right. So how many students watch 1 movie? 3 of them. How many students watch 2 movies? 7. 3 movies. 3. 4 movies. 2. 5 movies. 1. 6 movies. 1. All right. Lots of those. Okay. Great. Now again, this was a multiple choice thing. You didn't have to draw it by hand. You could have just looked at which ones made sense with the actual data. All right. All right. So next. So another one related to this. Okay, so here, given the following frequency distribution table for a set of data about the number of push-ups completed in a 60-second time period by the participants in a strength training class, construct a histogram that accurately summarizes the data. All right, so again, I'll do this. I'll do this how I would make one of these by hand. And then down here is just one of those where you just kind of move the dots around to create bars. All right, so here's how I would make one of these by hand. All right, so again, let me pull this up here. Okay, so again, you have the 2 axes. I'll try to write big. 2 axes. The horizontal axis is going to be the actual data values, right? Because what the recording is the number of push-ups completed. So numbers of push-ups completed in a 60-second whatever time period. Then the second column was just frequency. All right, frequency. And it looks like the highest frequency in there is 22. So maybe I'll go by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. All right, then for the horizontal axis. Now, do you see how, this is a range of numbers. In the last picture I made, we only had singular numbers, 1, 2, 3, that were showing up in our data. Here in our table, there's a range of numbers, or this is what's called a grouped table, a grouped data table. we throw all the 0s through 9s in this first group, and there are 6 of them. Right? So that means there could be a 1, a 2, a 3, a 5, a 7, and an 8, and a 9. There are six values from 0 to 9 inclusive. And then there are 10 values from 10 to 19. It's grouped data when you see these ranges or these intervals. Now one way to graph these would be to write all these lower limits. These are all these groups are called classes. Groups or classes. You have a lower class limit, so all these lower values are called the lower class limits. And then you have upper class limits, right? All these upper values. So you could just write down the lower class limit. So the first lower class limit is at 0. So 0 push-ups. And then the next lower class limit, the next class starts with 10. And then the next lower class limit starts with 20. And then 30. And then 40. And then I write the next one above that just to get the last bar in, because here we have 0 to 10, 10 to 20, 20 to 30, 30 to 40. That'll take care of the first 4 bars. But then for the last one, 40 to 49, I'll put in 50, right? And again, make sure everything has the same width, right? So here the class width, right, we would say that the class width, or the width of each bar, is 10 units as opposed to 1 unit on the previous one, right? The class width was 1. Here it's 10. All right, and then same deal. I make a little bar starting from one lower limit, to the next lower limit. So how many people did from 0 to 9 push-ups? 6 of them, right? So I make a bar that's 6 high. That's a rough marker there. So there's a bar that's 6 high from 0 to 10 there, right? Well, that represents 0 to 9. 10, the lower limit. The lower limit, that starts the next bar, the next class. And then from 10 to 20, so 10 to 19, right, I'll make a bar. That 10 people, right, 10 people did 10 to 19 push-ups. And then 20 starts the next bar, starts the next class. And 22 people, did 20 to 30, or 20 to 29, right? 30 starts the next class. And then 30 to 39, right? Between 30 and 40 here. That's 5 people, so between 4 and 6, so like this high. And then from 40 to 50, that's 40 to 49, 2 people. And so again, this would be the, if I were drawing it by hand, this would be the histogram I'd draw for that chart. Okay. But you don't have to do it by hand. I'm not going to do all these by hand. All you're asked to do is just move these dots around. So you see from 0 to 9 down here, you could just write the name of the class. See how they have 0 to 9, 10 to 19, 20 to 29. 0 to 9, 10 people. So this is one of those where you just move the dot. Be careful, it's a little it's very sensitive. Then from 10 to 19, I'm sorry, it was 6 people for the first one. I'm not looking at the right chart. So 6. And then 10 to 19 push-ups, 10 people. 20 to 29 push-ups, 22 people. Alright, and then 30 to 39 push-ups, 5 people. And 40 to 49 push-ups, only 2 people. All right, and there you go. There's that same histogram that I just drew, right? That looks pretty similar to what I have here. All right. Same shape, same distribution, right? When they say distribution, it just means shape. All right. Okay, and then submit. Looks good. Great. Continue. And then a question about this, right? You should be given, asked to interpret them as well. Here's a question about the histogram. According to the histogram, which range of values contains the highest frequency for the number of push-ups completed in a 60-second period? All right. So which range of values? So you can see here the third class there, 22. So that's 20 to 29 push-ups had the greatest number of people doing it. You know, the greatest number of people did 20 to 29 push-ups. Now you got to be careful here. Look at the wording. Greater than blah, but less than blah. If I put 20 to 29, I think that would be wrong. The reason is, you know, this is 20 to 29 including 20 and 29. So 20 is not greater than 20, right? 20 is equal to 20. So I'd say greater than 19, but less than 30. All right, greater than 19, but less than 30. That'll be from 20 to 29. All right, and in fact, just so this instructor cheat here, show you. See, it's okay. So I guess you just put in the range. The wording is incorrect. All right, the wording. So just put in the range 20 to 29. Sorry, just look at the bar. 20 to 29 had the highest frequency. All right. So just fill in the blanks with that those particular the lower range, the lower class limit, and the upper class limit. I don't like the wording here. I'm going to send some feedback later about this. All right. If you ever come across some issues with wording or the way an answer is, you can click on feedback and submit it to Newton. All right. So yeah, just put in the lower class limit and the upper class limit. Should be good. All right. Sorry about any confusion that might have caused. All right. All right, so I finished that create and interpret histograms. Now I'm on a new objective, right? No progress. Create and analyze histograms and frequency tables with group data. So this is where you're going to make your own table, and then that last group table that we saw, we're going to make that ourselves with lower class limits and upper class limits, and then the frequencies or relative frequencies. So again, so like I said, you fill in the lower class limits, the upper class limits, and frequencies. So how do I figure these out? All right, so we're going to go new objective. I'm going to go to more instruction. And now this is a video on doing this. And read the little note down here as well. All right, so here's the how-to. Now I'll read this out. How to construct a table, a frequency table for a grouped set of data, right, where we break data up into groups and classes, right, intervals. So step 1, determine the number of classes, and this will be told to you. All right, in a lot of the problems you're going to see, they're going to say, hey, make a frequency table with this many classes. So just pay attention to that. So this is the number of rows in the table. All right, typically the number of classes is between 5 and 20. Calculate that. Remember that class width that I mentioned, right? That's how wide each bar is going to be. And use the following formula. All right, class width. You take the largest data value, subtract the smallest data value. This is called the range. Right, where you take the largest data value minus the smallest data value. That's how far apart the data set is, how far spread it is. Then divide that by how many pieces, how many classes do you want to break the data up into. And then round up, always round up according to the precision of the data, right? So how many look at the data, what decimal points are the data recorded in, and you round up to the next highest. Always bump it up, bump this class width up to the next highest value in that same decimal place. So if the data are integers, round up to the next integer. If the data are expressed with one decimal place, then round up to the next tenth, right? Bump it up to the next highest tenth, right? And so on. Create a table. Create columns for lower class limit, upper class limit, or just the classes. I personally, when I write them out, and you'll see me write it out on a piece of paper, I just put classes, right? You'll see. And then frequency or relative frequency, we could do both. The number of rows is equal to the number of classes. Find the lower class limit for the first row, which is just the minimum value of the data set. All right, just the lowest value would be the first lower class limit. and then you just keep adding the class width to get the other lower class limits, and then find the upper class limit for each row, which will be just 1 unit less than the lower class limit from the subsequent row, and then you just count how many values are in each row. All right. Now it says fall between the lower class limit and upper class limit. I think they mean inclusively. All right, they mean inclusively here. So again, read these steps, and I'll perform these steps when we get to a problem. All right. So here, as part of an effort to reduce patient costs, a hospital analyzes the number of visits by a nurse for 13 patients over a 10-day period. The average number of nurse visits per day for these patients is given below. Construct a frequency table with 4 classes. Right? See, they're telling you how many groups do they want you to break it up into. 4 classes for these values, using the minimum value in the data set as the lowest class limit in your calculations. Okay. So I mean, I got this down here, but I'm going to show you on paper what I'm going to be doing. All right. All right. So let me blow this up a bit. All right, so there's the data. All right, right up here, all these values, and they're being really nice here. You see how they've already arranged it from lowest to highest? So that's great. All right, you're going to want to do that, and you can do that on your calculator, but these are already arranged from lowest to highest. All right, so first I'm going to calculate the class width. How wide should, when I go to make a histogram later, which I don't think they have us doing, but they might. When I go to make a histogram, how wide do I want each bar to be? So what's this class width? All right, so I mean, the formula was written up earlier. You take the largest value minus the smallest value divided by the number of classes, right? The number of pieces. So they told us they wanted 4 classes. All right, now what's the largest value? Clearly it's 13.0 minus the smallest value is 3.6. And then I divide this by the number of classes they said they want with 4 classes, right? It's up in the problem. All right. So 13.0 minus 3.6 would be 9.4. Pardon me. Then divide that by 4. All right. And if you want to pull a calculator up, you can. I mean, I'm not saying this is a silly one. 9.4 divided by 4 isn't insane, but if it gives me some crazy decimal, all right, so let's go 9.4 divided by 4 should be something 0.5, 2.35. All right, so this is equal to 2.35. Oops, I can't write. 2.35. Now, rid of that. All the data, all right, remember I said we're going to bump this up. All the data you see are to 1 decimal place. The most decimal places any of these data values go to is to 1 decimal place, the 10th place. So we're going to bump this up. I'm going to round this up to the next highest 10th because of the data. Round up to next highest 10th. Right? If there were any data values to 2 decimal places, I'd round up to the next highest, the next highest 100th. Right? Depends on what the data look like. So we're going to use a class width of 2.4. Right? We're going to use a class width of 2.4. All right, so now I'm going to make my table. All right. So I'm going to have my classes, class, and then how many data values are in each class frequency. All right. A column with class and a column with frequency. All right, so first come the lower class limits. All right, the lower class limits, starting with the lowest value, which is 3.6. So for the lower class limit for the first class is going to be 3.6, and it's going to go from 3.6 to whatever. Right? We'll put in the upper class limits later. So from 3.6 to blah, and then I just keep adding the class width plus 2.4 to get the next lower class limit. So 3.6 plus 2.4 would be 6.0 to blah. Right? Again, I'm not doing the upper class limits yet. And then same thing. I just until I get my 4 classes plus 2.4, that'd be 8.4 to blah. Right? Again, just the lower class limits right now. And then same thing here, plus 2.4 plus this class width all the time, and that'd be 10.8 to blah. All right, so I have the lower class limits in. Next, the upper class limits, which they mention it's just one lower than the subsequent row's lower class limit. So if this is 6.0, the upper class limit here is 5.9. Again, to the same decimal places, same number of decimal places. So 6.0, we're in the 10th place. One below that would be 5.9. That's the upper class limit for the first class. And then this is 8.4, so we have 8.3 here. This is 10.8, so we got 10.7 here. And do you see how all these upper class limits are just, again, 2.4 apart? 5.9 plus 2.4 is 8.3. 8.3 plus 2.4 is 10.7. So I just keep doing the same thing. Add 2.4, that's 13.1 for the last upper class limit. So here are all the lower class limits, all the upper class limits, and then we just count, right, to fill in the rest of the table, the frequencies, how many values are are from 3.6 to 5.9. Well, we got 3.6, 3.7, 4.0. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values, right? 5.5, then 6.7 is too big. There are 9 values in that first class. All right, and then from 6.0 to 8.3, how many values? Well, we have 6.7, 7.2, and then 8.7 is too big. So just 2 values in that next class, 2 values in that next class. Then from 8.4 to 10.7, there's 8.7, and that's it. 13.0 is too high. So just 1 value in that next class. And then finally, from 10.8 to 13.1 is 13.0, right? 13.0, that's it. Only 1 value. Okay. And that's, there you go. There's a frequency table for this particular set of data with 4 classes. And I would do something, if I wanted 5 classes, I would be dividing by 5 instead. But this is for 4 classes. And then you could take this and make a histogram. All right, you could make a histogram, using this same set of data. So here's that table. All right, and let me pull up another piece of paper here. And we could make a histogram using this table. I make vertical axis, horizontal axis. We have now these were all these numbers, right? All these numbers of data were visits per day, right? Average number of visits per day. So the data is represented by the horizontal axis, right? Visits per day, or average number of visits per day, whatever. And then the frequency going up. And we're going up to the highest is 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And then like I did earlier, I could just write, I could write the class number here, like the 3.6 to 5.9, 6.0, and then make bars. But typically I'll just write the lower class limits. So we have 3.6, then just evenly space them, 6.0, the next lower class limit's 8.4, the next lower class limit's 10.8, and then to get the next bar it'll be 13.2, right? Just add 2.4 again, add the class width. And then I make bars, so from 3.6 to 5. The first bar starting with 3.6 has a frequency of 9. So I make a bar that's 9 high, right? That represents the first class frequency. There were 2 values in the next one, so starting with 6.0, 2, then 1, then 1. Starting with 8.4, starting with 10.8, and there you go. There's a histogram. All right, this is a histogram for that same data with 4 bars, 4 classes. All right, but we weren't asked to do that just yet, right? We're asked to just make this frequency table. All right, so let's get rid of this, and or I'll just move this actually. Let's just move this over here. All right, and then we got our we go to enter our limits. Right, so lower class limit, we saw the first one was 3.6. First upper class limit, 5.9. The next lower class limit, 6.0. Then you see 8.3 there, it's already there. Then 8.4 to 10.7 is already there. Then 10.8 to 13.1. Then we have to enter the frequencies, which now let me get rid of my picture. Remember, there were 9 in the first class, 2, then 1, then 1. Right. And let's submit. Wonderful. Right. So the way I did that, right, worked out. And this, I just followed the same steps that were described in the more instruction. Right, they were described up here. Right, the how-to. All right. Then you go through it here. Continue. All right. Now, see. Histogram. It's the same set of data. Same set of data. And we're asked to, okay, as part of an effort to, it's the same thing, draw a histogram now for these values. It says use the black dots to adjust the edges of the bars if necessary. It says use the minimum value in the data set as the lowest class limit. All right. So remember how my histogram, all right, I'll bring that picture back up. All right, here's a picture. And this was the histogram I drew right here. And this is what we're doing. Okay. So notice how it ends here. You can't move 13.2. Just like mine ended at 13.2. So you see they're using lower class limits for the black dots. So the black dots I move, the first one was 3.6. Again, it's pretty sensitive. 3.6 was the lowest value. The next one, the next lower class limit was 6.0. So I'll start the next bar at 6.0. Come on. There. The next one at 8.4. The next one at 10.8. All using all the lower class limits there. Now you see how every single bar, right? Every bar should be 2.4 units wide. All right, that was that class width. The class width should be the width of the bars. Then the frequency, right? There were 9 data values in the first one. Then 2 in the second class. Then 1. And then 1 again in the last class. All right, and there. And that should be a good histogram for that data set with 4 classes, 4 bars. Okay, so the way I did it by hand is exactly how they're having you do it on the KnewtonAlta. All right, so I continue on. All right. Now they have the table already filled in for me, right? This is the same table that we just made, right, written out for us. And now they have a question, right? The hospital has found that if a patient is being visited on average at least 8.4 times per day, they can give the same patient care with 3 less nurse visits per day. So how many nurse visits per day can the hospital reduce for these 13 patients? So how many nurse visits per day can the hospital reduce for these 13 patients that are referenced here? Right? You see it add up the frequencies as 13. So they said that if a patient is being visited on average at least 8.4 times per day, they can give the same patient care with 3 less nurse visits. So how many patients are being visited at least 8.4 times a day? So that's 8.4 or higher. So there's one so I start here at the 8.4 to 10.7 class. There's one patient being visited from 8.4 to 10.7 times per day on average, and there's another patient from 10.8 to 13.1. That's at least 8.4. Remember, read carefully, at least 8.4. So there are two patients that are visited at least 8.4 times per day. And they're saying for each of these patients, they can reduce the number of nurse visits by 3. Right? They can give the same patient care with 3 less nurse visits. So how many nurse visits can they reduce? Well, there are 2 of them. They're reducing 3 each. That's a reduction of 6. That's a reduction of 6 visits per day. And again, read the answer explanation, goes over what I just said. All right. So and still group data, still the group data objective. All right, so still create and analyze histograms with the group data. All right, so here we have again another problem where we're given data in it, and it looks like they're being very kind, lowest to highest. I would recommend if you're not, you can use a calculator or do it by hand. Put the data in order from least to greatest. So a physician is investigating the effectiveness of the surgery she performs. So she investigates the amount of blood lost in liters for several of her past patients and reports the values below. Construct a frequency table for these values using 5 classes. All right, so again, I'll pull up my screen with the paper here, and I'll blow this up, move it underneath. All right, so let's get some new paper here. So if I'm creating a frequency table, right, I would, with this group data, break it into groups. They want me to break it into 5 classes, 5 groups. First, I want to calculate again that class width. How wide, if I was making a histogram, how wide should each bar be, right? So again, that's the largest value in the data set, which they've given me as 2.2, right? 2.2 liters of blood, minus the smallest value in the data set, 0.1 liters of blood. And we're going to be dividing this by 5, right? The number of classes this time is 5. All right, so 2.2 minus 0.1 is just 2.1. Then dividing this by 5, let's see. 21 divided by 5 is 4.2. So this is 0.42. All right, moving 1 decimal place left. 0.42. Now, I'm going to bump this up, remember. All right. Again, in this example, all the data are to the 10ths place. So I'm going to round this up to the next highest 10th, which would be 0.5. All right, so I'm going to use 0.5 as the class width, half a liter of blood. All right. Then when I make my frequency table, we have our classes and then the frequencies. Now the classes here was liters of blood lost. These numbers meant something. I didn't write this in the last example, but liters of blood lost, and then number of patients is the frequency. You count how many patients lost that much blood in these surgeries. So the first class, the lower class limit is the lowest value. The lowest value is 0.1, and you can see that here, right? 0.1. To the upper class, I don't have yet. All right, I'm just going to put the lower classes, and then I just keep adding. For the lower class limits, I just keep adding the class width. So plus 0.5, that's 0.6 for the next class to whatever. Then plus 0.5 would be 1.1 for the next lower limit. Plus 1.5 would be 1.6 for the next lower limit. Plus 1.5 would be 2.1 for the last lower limit, right? That's 5 classes. And then, the upper class, the upper limit for the first class would be 0.5, right? Just 1/10 lower than this lower limit. Then 1.0, and then I can just keep adding this for the upper class limits as well. 1.0, 1.5, 2.0, and 2.5. All right, and then we count. All right. So how many values are from 0.1 to 0.5? We have 1, 2, 3, 4, 5, 6 of them, right? From 0.1 to 0.5, there are 6 values there, right? So when I make my histogram, there's going to be a bar with 6, that's 6 high. From 0.6 to 1.0, there's 0.6, 0.8, 0.8, 1.0. There's 4 of those values, right? Then 1.3 is too big. From 1.1 to 1.5, we have 1.3, 1.5, then 2.2 is too big, so 2 of those. 1.6 to 2.0. I don't see any. There are no values from 1.6 to 2.0, so I put 0 there. So I'd have a bar with a height of 0. There'd be no bar, but you'd still have that width. Right? You'd still have the width of 0.5, but then no bar, a flat line on the axis. And then 2.1 to 2.5, there's just that value of 2.2. So 1 there, 1 value from 2.1 to 2.5. All right, so again, how to do that by hand, hopefully not too terrible. All right, so let me get rid of this and just fill in these same values in the assignment. All right. So we had, like I said, 0.1, 0.6, 1.1, 1.6, then 2.1, and then 0.5, 1.0, 1.5, 2.0, 2.5. All right. Frequencies were 6, 4, 2, 0, and 1. Okay, great. You got correct there. They go through the explanation. Wonderful. All right, so continuing on, then I believe they have probably a histogram with the same data. All right. Oh, I'm sure it's eventually, there it is. All right, so this is the exact same table I just filled in. All right. Now I'm making a histogram. All right. So as before, put the black dot, you see the end of it's at 2.6. That would be the the next lowest limit here. So just put the dots. Let's see. It says use the black dots to make correct make the correct boundaries for the bars for the histogram. Use the minimum value in the data set for the first lower class limit. All right. So yeah. So just like earlier, I'm going to have this start at 0.5. The first dot. I gotta move everything here. First dot start at 0.1. I don't know why I did that. 0.1, that's the minimum value. And then just put the black dots at the lower limits. Right? All these lower class limits, put the black dots at those. So then keep adding 0.5, right? So then 0.6 for the next one, 1.1 for the next one, 1.6 for the next one, 2.1, and then you see how 2.6 at the end that you can't move is 0.5 away. So the width of every bar should be 0.5, that class width that we decided. Then for the frequencies, right, from my table earlier, there were 6 values in the first class, then 4, then 2, great, then 0, right, so take this one down to the axis, and then 1. And there we go, and that there's a histogram, right, a picture of the distribution of the data. Right, pretty hopefully pretty simple once you've got the frequency table made. If you've made the frequency table correctly, you should be able to make the histogram pretty easily. Right, and then a question about it. Right, so same table that we just looked at. So it says new medical research shows that a certain technique can save half a liter of blood for surgeries that in the past have lost over 1.1 liters of that patient's blood. So according to the research, how much blood could this doctor have saved if she used this new technique? So you look at this table, they're saying that this only applies to patients who in the past have lost over 1.1 liters of blood. So I start at the lower limit of 1.1 here. Anything in this class, anything in the last 3 classes would have lost over 1.1 liters of blood. So how many patients was that? That's 2, 0, and 1. There are 3 patients she had that lost more than 1.1 liter of blood. So for those 3 patients, using this new technique, she could have saved them half a liter of blood each. So 3 times a half. So that'd be 1.5 liters of blood she could have saved if she used this new technique. Okay, so again, pretty similar to the previous problems. All right, so moving on. Almost a little 2 objectives done. Now you'll see the other objectives are pretty similar. This is complete frequency tables and histograms to analyze group data. It's the same objective. That's what I mentioned earlier with the videos. That's why I only have one video for one of the objectives, not both. The only difference between this one and the other one is now the data is not in order. Oh no. Okay. But it's still, okay, it's not in order. But you're still doing the same thing. All right, now this time we're asked to make a histogram. All right, now I'll show you later how to make a histogram with a calculator. But for right now, let's do it by hand. Now I'm going to use the calculator to put these in order. Okay, so I'm going to pull up a calculator and enter these numbers in a list and put it in order. And I'll just I'm just going to skip right to that. All right. So the calculator's up. Now there are some values that it's hiding. There are 3 values behind the calculator, right? 8, 20, and 19. But just bear with me here. All right, so I'm going to enter these values. Okay, so you're seeing here in the calculator, I've entered the 24 values that are mentioned there, and those are the numbers of boxes of nails purchased over the last several weeks. Right, so 7 boxes, 10 boxes, 10 boxes, 7 boxes, etc. Now, you've seen me do this before. If you want to take a list of data and put it in ascending order, you just hit Stat, go to Sort in ascending order, and then what list? List 1, second one. I have that down list 1. Hit Enter, and then when I go back to the Stat menu, and go to hit Stat and Edit, these values are in ascending order: 7, 7, 8, 9, 10, 10, 10, etc. All right, so let's do the histogram stuff. All right. I'm sorry. Let's make a table and then make a histogram. All right, let's make a frequency table. Now they asked us to construct a histogram. You see, using 4 classes. Right, 4 classes. All right, so I'm going to go to a paper again. I'll pull my calculator back up here. So this time I'm on the big screen. So we're asked to make a table, make a chart, and then make a histogram using 4 classes. All right. So again, to make that table, I start off again with the class width. So what is the maximum value? All right, what is the maximum value? So on the calculator, the largest value, now the lowest value is 7, and the largest of these 24 values, keep going up here, was 20. All right, so 20 minus 7, and then I'm dividing this by, now they wanted to make 4 classes. All right, 20 minus 7 is 13. 13 divided by 4, well, that's 3 1/4, right? 3.25. But, look at the data. Right? All the data, all these values in the calculator here are whole numbers. All right, so I'm going to bump it up to the next highest whole number. All right, so we're going to round up to 4. I'm going to use the number 4, the next highest whole number. And you should also do that even if this was 12 divided by 4, even if this was 3. If it was a whole number, I'd still go up to the next highest whole number. All right, to 4. So that way we get all the data when we make our table. All right, so now our table, class and frequency. The lowest value is 7. Right, so that's the first lower class limit. Let's turn this back on, sorry. Well, I don't really need it. And I keep adding 4. So the next class starts with 11, the next class starts with 15, and this fourth class, the last class, starts with 19. And then we have 10 here, which is 1 less than 11, then 14, and then keep adding 4, 14, 18, 22. So there are the classes. And then I count, and it's very easy to count how many are in each class when I'm on my calculator here. And just scroll back up to the top of my list. And we're first going to count how many are from 7 to 10. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's it, because 11's too big. So there are 9 values in that first class from 7 to 10. And from 11 to 14, there's 1, 2, 3, that's too big, so 3. 15 to 18, 1, 2, 3, 4, 19's too big, so 4. And then the rest of them, this is what, 12, 16 values. The last 8, because there were 24 values. All the frequencies should add up to 24. There were 24. The last 8 should be here. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. All the last 8 values, as I suspected, were there. All right, and then I make a histogram. Let's do that next to it. Really small one. So I have the numbers of boxes of nails. I'll just say numbers of boxes. And then how many times did they get that frequency, right? So I'll start off by writing 7, the first lower class value, then just keep going, 11, then all the lower class values, then 15, 19, and then get one last one in here to make sure you incorporate the last class, add 4, 23. And then the frequencies, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. First one, 7, the first class here has a frequency of 9 boxes. Not 9 times they ordered 7 to 11 boxes. There were 9 weeks where they ordered 7 to 10 boxes. Next class, 3. Right, 3. So there were 3 weeks where they ordered from 11 to 14 boxes. There were 4 weeks where they ordered from 15 to 18 boxes. And then there were 8 weeks where they ordered from 19 to 22 boxes. So up to 8 here. So I'm just going to make this on the computer, right? When I'm moving my dots around. All right, so let's get rid of the calculator in this picture. Move down. All right, so again, I'll start this at 7, the lowest value, the black dots, and then just keep adding 4. All right, keep adding that class width. 11, 15, 19, and 23, right? I said 19. Right. Keep adding 4. All these are 4 apart. There were 9 in the first class, 9 weeks where they ordered that many boxes of nails, and 3 for the next, right, 3 for the next, 4 for the next, it's already there, and then 8 for the last class, and this should be good. Okay, and then they're probably going to ask me a question about it. So yeah, so here it is, histogram, all that. Eddie also knows that the number of nails he purchases directly relates to the number of projects he currently has. Specifically, he makes the following assumptions. If he orders, under 11 boxes of nails, it indicates that he has 3 projects during the week. If he orders at least 11 but under 15, so from 11 to 15 boxes of nails, well, 11 to 14, right? At least 11 but under 15. So 11 to 14 boxes of nails, that means he has 4 projects that week. And if he orders 15 or more boxes, at least 15 boxes of nails, that means he has 5 projects that week. Based on these assumptions, how many total projects did Eddie have over this period? All right. So under 11 boxes, that's his first class. 3 projects during the week. So there were 9 weeks where he ordered under 11. So 9 times 3 is 27. All right, so it's 27 there. I'm just going to kind of say these out loud. So 27 projects there in those 9 weeks. Then from 11 to 14 in those weeks, there were 4 projects a week. So there are three weeks where he ordered 11 to 14 boxes of nails. So 3 weeks times 4 projects, that's 12 more projects. So we have 27 plus 12. And then 15 or more boxes of nails were 5 projects a week. How many weeks did he order 15 or more boxes? That's these last 2 rectangles. 4 and 8 is 12. Right? There were 12 weeks where he ordered more than 15 or more boxes of nails. So 12 weeks with 5 projects a week, that's 60 more. 12 times 5, 60 more projects. So add those up. 27 plus 12 plus 60. That'd be 99. 99 projects total over this period. And again, you read through the explanation. It's exactly as I said, just looking at those bars. Right? All right, so another one, again, very similar, where you make your own. Now this one I'm going to show you right now. I know there's another objective coming up where you show how to do it on your calculator. I'm going to show you how to make a histogram on your calculator right now. All right. So here, Jack started a new business where he sells items online. He would like to know the amount of traffic his website receives for a typical hour of the day. The number of visits, in thousands, his website received for randomly selected 1-hour intervals are given below. So 13.4 thousand in 1 hour that he selected, 5,100, 5.1 thousand in another hour, and so on. Now again, the only difference between this and previous problems is that this set of numbers here is not put in order. Right. Construct a histogram for these values, again using 4 classes. All right, so just as before, I'm going to enter these values into my calculator and rearrange them in order. All right, so I'll have that pop up in a second. Okay, so I've entered these values, values here, and then had them rearranged in order from least to greatest. All right, so now I'm going to, again, kind of skip ahead and I'll make a table. All right, I'll make a table, and in a minute I'm going to show you how to also use your calculator 8483 to make a histogram like I'm going to make in a second. All right, so I have gone ahead and taken this list of data, All right, the list of data that I've entered, there's 12 values that are in order from least to greatest, and calculated, the class width, right? Remember, it's the largest value, 13.4, minus the smallest value, 4.5, divided by the number of classes. There's 4 classes here. This came up to be 2.225. But all the data, right, was to the tenths place. So I round this up to the next, bump this up to the next highest tenth, 2.3. And made the classes, the lower class limits, upper class limits, and then counted. I made all these the way I had in the past couple problems. All right, and then for the histogram. All right, now how you make a histogram on your calculator? All right, I will show you right now. So let's quit here. All right, so I get out of the table, and then I go to the same place you went for line graphs and bar graphs. So stat plot, and then go to plot 1. Just turn plot 1 on, and then the third one, when it says type, the third one is a histogram. It's a bar graph, but a histogram is a type of bar graph. And then what's the list? Now I have this down list 1 again, just L1. And all of them are counted one time, right? We're not doing anything with frequency tables just yet. Right. Then I'm going to get out of here. Now you could just go graph and hit that zoom and zoom stat, but that'll make something that doesn't have the exact same width. So I'm going to go to the window, hit the window button, and I'm going to set it up so that I get the same classes and class width that I have on my paper here. So the X-min, X-max, I'm going to have it start off with, have the X-min be just the lowest value, the lowest class value, 4.5. The X-max, all right, I'm going to have the X-max be that if it's a little weird, but if I were to go to the next one, it'd be 13.7. If I were to go to the next class, if there was another class, I'm going to have that be my X max, 13.7. And then this X scale, this is going to give me the distance between some notches. This is going to be my class width, this X scale, which is 2.3, right? The class width, 2.3. All right, then Y min and Y max, Y represents the vertical. I'm just going to have it start at 0, maybe negative 0.5, so that way I see below the axis. And then, this is just for frequencies. The highest frequency I see here is 5. So let's go up to like 6, all right, for the Y max, and then just have each one be 1 apart, represent 1 unit. And then when I hit graph, see, here comes our histogram with 4 classes, 4 bars. Now let's hit let's see what happens. Let's hit trace, and you see how the first one, see, from 4.5 to less than 6.8, 4.5 to under 6.8, that's the first class, and you see there are 4 of them. 4 of them. Move over, hit the right arrow, from 6.8 to under 9.1. See it says less than 9.1. That's 6.8 to 9.0. See, there's only 1 of those. 1. Then move over. From 9.1 to less than 11.4, that's 9.1 to 11.3. There's 2 of them. And then the last one, from 11.4 to less than 13.7, that's 11.4 to 13.6. You get 5. See, the n equals 5. So that's how you make a histogram. I wouldn't do, the zoom stat. I wouldn't do that for making a histogram, because I got to set up these widths, these classes, so that the bars are all the same width apart. I want to use my class width and my class limits. All right, but that's how you make a histogram on the calculator. All right, and back on the assignment, I'm going to enter the same stuff, right? You go down here. remember all the black points are going to the lower class limits, so the first one here at 4.5. Then I just keep adding the class, so 4.5. Then I keep adding 2.3, right? The class width was 2.3. So the next one at 6.8. The next one at 9.1. 9.1. The next one at 11.4. And the last one at 13.7. So that way every single one of these is 2.3 apart, right? And then the frequencies, right? There were 4 hours in the 4 in the first class, 1 in the second class, 2 in the third class, and 5 in the last class. And there you go. That picture, see, looks like the picture on my calculator, right? Picture I've got here, just with colors and stuff. All right, so submit. Looks wonderful. All right. All right, so let's get rid of the calculator. All right, and then we're probably going to be asked some question about it, right? So here, when Jack looked at the accompanying histogram, he noticed that there were some hours with a lot of traffic and other hours with very little traffic on his website, right? What percentage, right? What percentage of these 1 hour intervals had either at least 11.4 thousand visits or less than 6.8 thousand visits? All right. So there are a total here. Now, if we're going to calculate percentage, we got to know how many there are total. There were 5, 2, 1, 4. Right, that's 12. There are 12 hours he looked at. And what ones had at least 11.4 thousand visits? That's this last bar. So 5 of them. Or less than 6.8. That's the first one. 4. 5 and 4 is 9. 9 out of 12. 9 out of 12 of these hours satisfied these conditions. Now, to the nearest percent, 9 out of 12 is 3/4. That's 75%, right? And they just said, you know, put your answer below. Now, I don't know. They didn't say anything about not writing a percentage. But they asked what percentage. So I'm just going to put 75 and see if that's okay. Yeah, so they didn't need percentage there. Right? But yeah, it says, you know, if you're counting percentage, you got to calculate the total. It's like relative frequencies, you know. All right, so then the last objective is making it on the calculator, which I already showed you one. All right, so I'm going to show you one more. Now, as before, you've probably seen, you don't need, you know, you could probably figure out, you know, you could draw it by hand and not do it on the calculator and still get this stuff. But I would recommend, you know, doing the calculator. Now, it is a new objective, so let's click on the more instruction, have them show you how to make it on your calculator. All right, so you got the how-to here. So I'll work through the how-to. All right, I'll do it the way they're doing it. Now they do use the zoom stat and then change the window. Remember how earlier I changed the window, the X-min, X-max and all that? I just did that first and didn't worry about the zoom stat. I'll do that here. I'll follow the same steps they have and show you what you get. All right, and then we'll change the window. All right, so you can read the example they got there. I'll just go through a problem. All right. So the owner of an electronics store randomly selects 10 daily production reports and records the number of extended warranties sold from each report. The data recorded are shown below. Use a calculator to create a histogram of the data. All right, so notice there aren't any fixed number of classes that they want us to have. So in this case, you'll just use zoom stat. All right, when I was told how many classes I needed, then I needed to, you know, make sure that my calculator histogram fit my drawn histogram, my hand-drawn one, right, fit my table. But they aren't telling me how many classes there are, so I'm just going to use the zoom stat and not even worry about, you know, how many classes they're supposed to be. All right, so I'll pull the calculator up and just going to enter these 10 values in a list. All right, so I'm just going to do that and come right back. Okay, so I've entered the 10 values here, and you don't have to put them in order if you're just going to have the calculator make it for you. I've been putting them in order because I wanted to do things by hand earlier, but since I'm not doing anything by hand this time, I'm just going to have the calculator make a histogram. I don't need to put things in order. All right, it's going to like do that automatically. All right, so simple as let's get out of here and just have it make a histogram involving that data. All right, so second stat plot. Go to plot 1, make sure it's on so you can see the graph. Make sure that third type is blackened, right? The one with the bars. That's for a histogram or a bar graph. And then what's your list of data? That was list 1, L1, or whatever list you had the data in. And again, we're going to keep frequency to 1 right now. Right? There'll be other times in the future when we'll change frequency, but for right now, every single piece of data is counted 1 time, right? This is counted, this is counted once. This 2 is counted once here. 3 once, 2. This is 1, 2, 1, 0, 1, 2, and so on. Everything's counted once. All right. So let's get out of here, and I'm just going to go straight to zoom and hit the number 9, right? Zoom stat, and there's a histogram made by my calculator, and it broke it up into 5 classes, right? Notice how in the problem it didn't say anything about the number of classes. So just use it says, just use the default settings. All right, so going back on the page here, which one looks like the one I got there? It looks like that second one. It looks like that second one is the histogram that comes up. So I click on that. And if we want to see what these mean, right, go back to the calculator, hit trace. And it tells me that 2 of them were from 0 but less than 1, right? So there were 2 zeros. Right, there were 2 zeros, and if you go back to the assignment, look, there were 2 zeros. Look at that, 0, 0. Move over. It says there's n equals 1. One value that was 1 but less than 2. All right, from 1 to 2 but less. So just 1, 1, 1. You can clearly see there's only 1, 1. All right, then the next bar, there are 4 2s, right? You see there are 4 2s in this list. And there are 2 3s and 1 4, right? 2 3s and 1 4. So perfect histogram for this. All right, so I put in a histogram that I saw, submit. Looks good. Then they might ask a question, I think, about, no, doesn't look like it. Move on to the next one. All right, so this one, same thing. Use a calculator to create a histogram of the data and then interpret the plot. Set X, now this one they're asking me, look, see, set X min to 500, X max to 1000, and X scale to 100. All right, so I'm going to do that and with this set of numbers here and come back when I have it for you. Okay, so I've done this. I've entered the list. Down list 1, I made a histogram, hit zoom stat, and then I went to the window. Right, so back here, after I did zoom stat, I went to the window and changed what they wanted: X min to 500, X max to 1000, and X scale to 100. And then hit graph again, and you can see the histogram that pops up here. All right, and interpret it. Right, if I hit trace, means that there are 2 values from 500, but from 500 to 600, but less than 6. So 500 to 599. Right. And there were 3 values from 600 to 699, 2 values from 700 to 799, 2 values from 800 to 899, and only 1 value from 900 to 1000. Right. So now back on the assignment, it says select the correct answer below. The histogram shows a left skewed distribution. All right. Let me talk about this real quick. Let's talk about skewing. All right. So distribution shapes. You have a uniform. A uniform distribution is kind of flat. Right, so if all the bars were about the same height, right, this is pretty flat. left skewed means it has a longer left tail. Longer left tail, or it's taller on the right. It sounds weird, but taller on the right. So something like this, where it's like low on the left here, and then gets really big on the right side, and kind of right where this is more flat. So a longer left tail, bigger on the right. That's called a left skewed distribution. Right skewed is just the other way around. Right, it's a longer right tail, or taller on the left. Longer right tail. So something like this, where it's big on the left, and then thin on the right. Right? Something like that. A long, thin right tail, but bigger on the left. And one we'll see a lot of is called a normal distribution, where it's kind of bell-shaped, where it's low, then high, then low. So something like that's low to start with, gets higher and higher, and is very symmetrical, and then it starts getting lower again. So it's got like this bell shape to it, peak in the middle, thin on the ends. All right. So just a real quick introduction to distribution types. There's more, of course. There's more kinds of shapes you can have. All right. So looking at our distribution here, it's kind of bigger on the left. All right. It's higher on the left than it's low on the right. So this would be like what they call a right skewed. Right. High on the left, low on the right. The right tail's longer. This would be more right skewed. All right. So go and get rid of the calculator here. So I'm going to say it's either the third or fourth thing. The histogram shows a right skewed distribution, indicating that most meals are on the lower end of this range, with a few that have a higher number of calories. All right. Remember, right skewed means that most are on the lower end, most are on the left, and a lower number on the right. Right skewed means that most. No, this means right skewed. Okay. Okay. So. Just look at the shape. All right. So again, again, you would just enter this list, make a histogram, and just hit zoom stat. Just go zoom stat, and pick the correct one that matches. I'm just going to put the cheat in here. We're at the end pretty much. So this is first one. Again, you can do that on your own. And same thing here. Again, notice there's no number of classes. They're not saying do so many classes or change. They aren't even saying change the window. Just use the default one. So again, I would enter this list of data, have it make a histogram in the stat plot, and then hit zoom stat and just leave it. And again, I'll just do the instructor cheat, and you'd be getting something that looks like this, which would be kind of another right skewed, right? It's heavy on the left, low on the right. That's right skewed. And left skewed is low on the left, heavy on the right. And I think that will be it. Okay. So a lot of stuff there, about an hour and a half. But again, you can thinking of these as these are my lecture videos, right? These are exactly probably what I would have been doing with you if we were meeting in like a Zoom meeting or something. All right. So if you have any questions, of course, let me know. And please do the reading of the OpenStax book. Practice some examples there. Watch some videos from the page for section 2.2. Take notes on that. Do the KnewtonAlta assignment. And again, I would recommend every time you see a new objective, click on more instruction and work through the problems that way. If you don't click on more instruction, I think you might be able to get through a little faster. But I would recommend, just to see the material again, just to keep, learning. The more you see something, the better you're going to pick it up usually. So every time you see a new objective, click on more instruction. Every time you're struggling with a problem, click on more instruction. And if you have any questions, of course, let me know. And hopefully this was informative. Hopefully, again, you can use these as a guide through, when you attempt the assignment. And you don't have to do the assignments in one sitting, right? You can break them up piece by piece, do some today, a little bit tomorrow, a little bit tomorrow. So you don't have, just because it took me this long to do it in one sitting, you're not going to be doing it all in one sitting, I hope, right? Just do what you can, whenever you can. I've been saying this a lot in my emails to you, right? I would recommend taking at least an hour every day to get work done in the class, and that way you'll not be overwhelmed at the end of the semester. All right, thank you for watching.